Hi, my name is Dean Simmons. In my 11th year and first, I'm mechanical team lead and lead designer for FTC Team Targets 5356. The Decode season has been filled with many firsts for the team, especially in design. Coming out of last year, I knew I wanted to push the team to create our first ever parallel plate competition robot. Us on the design team had felt limited by the off-the-shelf parts, but we faced a lot of skepticism from our coaches and teammates because we would need to CAD the bot fully ahead of fabrication for the first time ever. To prove we could do this, I CAD'd 4 separate drivetrains over the off-season to practice packaging on tight timeframes and with tricky subsystems, like bare motor drivetrains. The parallel plate we use on our competition robot grants us new accessibility to tighter packaging and more sophisticated design, with the use of master sketching, a process I advocated for this year and implemented very successfully. All of our dimensions are in one place, so there are never any issues with parity across parts when we edit dimensions. Our biggest innovation this year is our power takeoff system. This isn't just new to us, it's the first PTO in our region and among the fastest lifts we've seen in the world. We use a clutch system to redirect the power from 4 drivetrain motors to power our parking garage lift for endgame. It was a system I first tested in the off-season with help from my FTC friends online from places like Romania and Texas. Learning from a team in California, we integrated a brake pad onto the bottom of the bot to help with defense. This was a system I had very little involvement in on purpose, as we used it as a learning opportunity for one of our sophomore designers. The pad system is his first part integrated onto a competition robot. We used the brake pad with our PTO lift sequence to prevent the robot from driving backwards out of the base zone, a problem that caused us to lose a lot of points at our first qualifier. Collaboration and teamwork was vital during design critiques, where I was able to provide feedback to the designer. I spoke from my past experience and furthered our team's sustainability goals of making sure it's a smooth transition when seniors like me graduate. Our intake features custom molded silicone wheels, another feature I introduced to the team after hearing how good they were from my online friends. We were able to tune diameter and squishiness beyond what off-the-shelf products allow. The intake feeds into our transfer, which was redesigned after second qualifier. Originally, we intended to play for all 6 ranking points available in Decode. Our sorter and kicker were slowing down our overall scoring, and we weren't earning many motif points. After a SWOT analysis with my team, I advocated for a redesign and going all in on 5 of the 6 ranking points. I used the decision as a teaching moment for the younger designers on my team, encouraging all of us to learn from our first qualifiers and adjust our strategy. Today, with a new direct feed ramp to the wheels, we can shoot rapid fire, dropping our 3-shot cycle time from an average of 3.74 seconds to under 1 second, enabling us to achieve the late season goal RP. We're constantly learning from and streamlining the robot and maximizing points scored, even when it means redesigning a subsystem, like the transfer, from scratch. This custom foundation supports the subsystem that I've worked most intensively on, our shooter, which is now in version 3.3. I've been the lead in its development and have held critical design reviews of each version with our mentors and my teammates. We competed at early season competitions with this, our aluminum 2.7 shooter. It looked great, but that's about all it did. It was incredibly inconsistent, which we hypothesized was due to overcompression of the artifacts. We had created a problem with ourselves, though, when we fabricated the shooter out of aluminum. We couldn't change its dimensions. Earlier 3D printed prototypes had appeared unstable in testing, so when we felt we had a good enough design for V2, we cut it out of aluminum. To be competitive at the regional championship, we knew we needed a redesigned V3, but I wanted to be able to test and iterate, which mandated a 3D printed solution. To address the concerns about stability, I added structure by making our counterrolleys dead axles. Now, we have 2 steel beams holding the hood together rigidly, instead of the aluminum spacers and 3D prints that held together the V2 shooter. Because of backspin, we added a counterroller on our V2 shooter. We saw some improvement, but we added a second counterroller to V3 for increased contact time. Now, we have barely any backspin and much more consistent shots. I've worked on this bot with feedback from my friends and mentors all over the world, which is the thing I value most about robotics, the community. In New York, there's an amazing community that I'm proud to be a part of. I try to give back to what's been given to me, such that I've printed parts for 7 different teams in one day when helping host our local qualifier, and have skipped lunches at competitions to help rookie teams swap all 4 of their drivetrain motors, like at a qualifier last year. I never did get to eat my bagel sandwich. Robotics has taught me we're always more powerful together, with the strength of teamwork, sportsmanship, team spirit, and gracious professionalism. I'm Dean Simmons, and I can't wait to continue my robotics journey at WPI.